the following formula is called integrate by parts. Although it looks quite complicated, it's not that complicated. So if you want to take the antiderivative of the product of two functions, then sometimes it can be useful to use this. Then you only have to take the antiderivative of the first one times the second one. Then you take minus product of the antiderivative of f and derivative of g. Then you take the antiderivative of this. So let's say, for example, that you want to find the antiderivative of this one. And that's not so simple, because this one here complicates things. If this were not here, then it would be simple. Then the antiderivative would just be this one, that is raised to the power 8 divided by 8. And that works because the inner derivative here is 1. However, now we have an x here, and then we can't do that. But then we can use this instead, because this allows us to get rid of the x here. And here, this one will take the role of f, and this one will take the role of g. So first we need to take the antiderivative of this one. And that's just this one. Then we should multiply by g, and that's just this one. Then we should take the antiderivative of f again, and that's just this one again. And then we should multiply by the derivative of g, that is the derivative of x, which is just 1. And now we see that we've gotten rid of x, so now it's easy to find the antiderivative of this one. So now we only have to find the antiderivative of this one, and this is just a constant that follows along. Then the constant 1/8 just comes along, and the antiderivative of this one is just this one, plus c. Now we can factorize out this part, and then what remains is just x. And here it remains x plus 1 divided by 9. And this simplifies to this. And here we can take out 1/9. So we finally get this one. So we see the antiderivative of this one is this. And that we have found by using integration by parts.